Now that we've looked at a whole bunch of different function types, we're going to look at 3.4, direct inverse, and joint variation. We actually did direct variation last year with simple ideas such as, what if you and another family member get an allowance, you and your brother, and your brother's older, so they always get twice as much as you do? That would be joint variation. And so last year in Algebra 2, we saw an equation like this, y equals a times x, where if you use my example that I just did, which is that if we looked at allowance, if we said that whatever you make, so your x, if you make $2, they make twice as much. They make 2 times 2, which is 4. If you make $3, they make 2 times 3, they make 6. 2 to 6, 2 to 3, 2 to 4, and then 3 to 6. If you make 8, they make 16. That means that this 2 here is called the constant of variation. So no matter what you start with an allowance, their allowance is double that. So it's double is consistent between whatever weeks you get allowance. We call that the constant of variation. And we looked at that last year as multiplication. It was part of our linear unit, and we said that those equations always go through the origin. So if this was this example, we would go up to over 1. It would look like this on a graph. So if you made $2, then they made $4, $1 goes to $2, etc. So 2 equaled a, the constant of variation. So proportionality goes into this. You can also look at as if you said y over x equals a. So if you divide both sides by x, you would have this as a ratio, and that is a big part of these problems as well. So we're going to take this to the next level this year with direct, inverse, and joint variation. We're going to look at direct variation, which means that as one gets bigger, the other one gets bigger. So this is an example of direct variation. So as x gets bigger, y also gets bigger. Okay, so direct variation. We're also going to look at inverse variation. And that comes from the equation that we just looked at really for the first time in our chart of functions, which is a graph that looks like this, where we have this kind of curve to it. And if you remember, we called this y equals 1 over x. With inverse variation, we still have to have our constant of variation. So we're going to say that this is 1 over x times a, or a over x. So x goes in the denominator for inverse variation. And what does that mean? It means that as x gets bigger, so I'm going to use the same example that I used up here, but as x gets larger, notice that y is getting, so x is right here in the beginning and y is up here. As we move x getting bigger, now y is smaller. Y gets smaller. And the same thing happens over here. As x grows more negative, y grows larger in the negative direction. So this is inverse variation. And we still have the constant of variation. We're still going to call that a. Or we would have last year. The book is going to call it k. So k for constant. So I'll start changing my examples to match this book. So it's going to be y equals k over x. Or you could say y equals 1 over x times k. It's the same thing. It's just two ways of looking at it. But note that for inverse variation, the x goes in the bottom. So they will have this shape to the curve. So inverse, anything that you see inverse, anything described as inverse variation, puts that variable in the denominator. So it might not always be x, it might be something else. All right, so what we've done is we've taken what we saw last year and we're going to expand on it. So now we have what's called inverse variation as well as direct variation. And we have a third way of describing it, which is going to be joint variation. So joint variation means that you're going to have more than one variable. Additionally, any of these three types could have different exponents than we would have last year. So joint variation, inverse variation, and direct variation are all going to be given to you in words, and you're going to translate it into math so you can figure out that K for constant. Note that all three flavors are some sort of multiplication or division. So joint variation is going to be more than one variable multiplied or divided. And the only time it's divided is if it says inverse. Okay, so let's look at some examples and see if we can work some problems. So I have for you a very basic example of what kind of things you'll see. So they'll be written out in words. Suppose y varies inversely as the nth power of x. So we're going to rewrite this as math. Because y varies inversely, this varies means that it equals k. So your book uses k as the constant of variation. That means it doesn't say y is equal to or y is. It says y is going to change by whatever this k constant is. So it's just like the allowance, okay? You don't get the same exact allowance as the older brother. You got twice, or he got twice as much, so it varied. If you got 2, they got 4. But it wasn't that it was equal to. If you got 2, they got 2. So here we go. Y varies inversely. So I'm going to write this in math. Y varies means equals k. So this part goes together. Inversely as the nth power of x. So this piece means that x is raised to the power of n. So that's like an exponent. Inversely, I said before, inversely means that it's going to go in the denominator. So we're just going to say k over x to the n. So we have rewritten that mathematical statement into an equation for our first example. We haven't solved anything, we're just setting it up to show you how to do that. Okay, here's our first example. Looks like a whole lot of words, but we're going to make this pretty simple, okay? You can pause it and write everything down, or you can just write the important bits. The weight of a person relative to the earth is inversely proportional to the square of the person's distance from the center of the earth. So we're going to rewrite that in math in just a sec. Then the question is, using a radius of 6,370 kilometers, how much does a 180-pound man weigh when he's flying in a jet 9 kilometers above the Earth's surface? So we're saying he weighs a different amount when he's flying in the plane because he's so high up. So let's take this first part. We've got weight is inversely proportional. So that's the first part of our equation. To the square of the distance. Okay, so I'm going to take those things that I've underlined and rewrite them in math. I'm going to say weight with W. It says is inversely proportional. That means two things to me. It's not equal to it. It has to be equal to that constant of variation. So is inversely starts out the equals K. Inversely tells me that whatever follows the square of the distance is going to be in the denominator. So inversely means put it in the denominator. So I'm going to say square of the distance is distance squared. So I want you to take, and I underline stuff because I had mine all written out. I want you to take the words and I want you to find them and write them in order how they go in the equation. So weight is proportional, that's K. Inversely says that what follows, square of distance, goes in the denominator. Now we're going to take this equation, W equals K over D squared, and plug in the things that we know. First, we have to find out exactly what the K value is. So K is going to be the constant no matter where he is, whether he's on the surface, where he's in a plane 9 kilometers above, 12 kilometers above. This K is going to be the same. So we're going to plug in the 180 and what we know to be the distance and find out what the K is here, because we don't know the weight that goes with the 9. So we're going to use the weight that goes with the distance we know. So that's weight and distance we know. We'll be able to find K. Because obviously, if this is here's the Earth. If this is the distance of the radius, this is the man standing on Earth right now. Hopefully that makes sense to you. So I'm going to plug those things in. I'm going to say that the 180 pounds is his weight. It's equal to K over the distance from the center is 6370 squared. I'm definitely going to use a calculator. I'm going to say that K is equal to 180 times, so if I multiply this side by 6370 squared, it will cancel on this side, and then it will be on this side, 6370 squared. And let's find out what the K value is. So we have 180 times 6370 squared equals, K is equal to, and the book has made this in scientific notation, but I'm just going to write down what they have here. So 730,384,2000. Okay, so that's what K is equal to. So the actual question is, what is the weight when he's higher above the Earth's surface? So if he's in a plane, he's going to be out here. So we have to take the 6370 and add another 9 to it. So now we don't know the W, that's the question mark. We know K, because K is a constant. That'll be the same for anything we tried to weigh in this problem. And the distance now is going to be radius plus another 9, so 6379. 6370 plus 9 will be a 9 there, squared. This is easy to put in my calculator because I already have this value. So I'm going to say this value divided by 6379 squared. And so he weighs a little bit less. He weighs 179. I don't know why I put a decimal there. He's definitely not that light. 179.49 pounds. So he's further away from the center of the Earth and he weighs less. That's why when astronauts get out into space and they're so high up that they're past the influence of gravity, they're weightless and they float. But he's not there yet. He still weighs 179.49 pounds. Okay, let's look at our first example that has the word varies jointly in it. So varies jointly only means that we have more than one variable. So if it says jointly and inversely, that extra variable will go in the denominator. If it just says jointly, then they're both going to go in the numerator. This is a regular equation, a regular geometric figure that you would have done in geometry. But let's look at the equation of it in terms of proportionality for this exercise. So it says the volume of a right circular cylinder, which means a can, okay? So it means that you have a circle on the bottom and a circle on the top, and it's connected so it looks like a can. But there's a right angle here. That's what makes it a right circular cylinder. It's not like a can that went sideways like this, okay? It has to be straight up and down. Okay, the volume of a right circular cylinder varies jointly as the height and the square of the radius. So that means that we're going to take, let me find the words that are most important here. The volume varies jointly as height and square of radius. So those are all the things that I need to put into math. I'm going to start with volume. The volume varies jointly. That means it's not equal to, but it's equal to the constant equals the constant. So varies means it's not the same every time. There's something that's multiplied. If it was equal to, we would leave off the k. This whole section is going to have k's though. The volume varies jointly as the height, and the square of the radius squared. So this is supposed to represent the volume of a can. Now, if you remember back to geometry, it's the area of the circle, which is pi r squared, times the height. So it's like you add up every circle going up the cylinder, circle in the bottom, circles in the middle. So it's going to be, k is actually equal to pi in this case. It's pi r squared, the area of a circle, times the height. So in this particular case, k equals pi. And that's the case with all circles. That's that constant proportionality playing there. So I just wanted to show you how you, again, take the words and put it into math. Your homework problems start out here. So let's look at an example from homework to see if we can rewrite these. This example 3 says A varies directly as the product of B and H. So you have to use all of your math word knowledge to know what these things mean. We learned that varies directly means equals K. We know that product means multiply. Okay, so here we go. A varies directly equals K as the product multiply B and H. Boom. We have taken, this is supposed to be equals, but it came out ugly. Let's rewrite it. Okay. Equals K BH. And that's all there is to that particular example. In other examples, they would say if A equals 3 and B equals 2, H equals 6, what is K? That's a K. So what you would do is you would say, here's the equation, plug these things in. A equals 3, 3. K, I don't know yet. B is 2. H is 6. That's mathematically 3 equals 12K. Divide by 12. And K equals 1/4. So we did this last year. We wrote it out here first. We found K, and then we rewrote it again with K in the problem. So this represents all of the proportionality of this situation with A varying directly as the product of B and H, where one example is this one. So we could plug in anything that has an A and a B and find out H, or a B and an H and find out A. This represents all of the situations like this one, and we could solve for other variables. Okay, so in your homework you have to try some of the problems rewriting them and then solving for them. We'll go over these tomorrow, and then we will do some more practice with some of the harder word problems. So you have a day of more basic practice, and then once we get good at that, we'll try again with harder practice. So tomorrow's video won't come until we go over the homework, because this is the lesson. Everything I've taught you tells you about direct variation, inverse variation, and joint variation, but it's going to take the practice. Then we'll go over those questions, post the solutions video to homework, and then your next assignment will be to practice harder problems. All right? Okay, thanks. See you next lesson.